Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through congruent triangles. So this video is all about testing and proving two triangles are congruent. So we went through the definition of congruence in a previous lesson. So recall that two shapes are said to be congruent if they're the same size and shape. This means that they have pairs of equal sides and pairs of equal angles. So remember, they're congruent if one shape is just a reflection, translation, or rotation of the other shape. So for example, let's say we have these two shapes here. So these two shapes here would be congruent. They're the same size and shape. They have 1, 2, 3 pairs of equal sides and 2, 3 pairs of equal angles. So they are congruent. They have the same set of sides and same set of angles. Now, I did tell you that two shapes are congruent if one is just a translation, reflection, or rotation of the other. So this is just a translation of the first shape. But we can't use that anymore in order to determine whether shapes are congruent. We can't just look at them and say, oh yeah, a reflection or a translation or a rotation has happened. Why? Because it's only a reflection, translation, or rotation if the pairs of sides and the pairs of angles are equal, if they are the same size and shape. So that's what we're testing here. We're not testing has a reflection, rotation, or translation occurred. We're testing whether the two shapes have all pairs of sides equal and all pairs of angles equal. So all we're going to do from now is look at two triangles and determine whether they have pairs of equal sides and pairs of equal angles. Now, you're probably thinking to yourself, oh, wouldn't that get a bit tedious? Well, it would if we had to test whether each pair of sides and each pair of angles is equal. That would be a lot of work. Fortunately for triangles, and this is only for triangles, we can take shortcuts to determine whether or not they're congruent. So what we do is we use one of the tests for congruence. So there are 4 tests you need to know: SSS, SAS, AAS, and RHS. So in all of these tests, S means side. More specifically, it means that the two triangles have a pair of equal sides. A means they have a pair of equal angles. And then the R and the H only occur in the last one. So the R means right angle and the H means hypotenuse. So remember, in an earlier lesson, I told you that that was the longest side of a right angle triangle. So this last test can only be used to determine whether two right angled triangles are congruent, but the other 3 can be used in any types of triangles. So what does this mean? Well, let's look at the first one, SSS. So remember, if two triangles are congruent, then they must have pairs of equal sides and pairs of equal angles. This SSS test is saying that if they have 3 pairs of equal sides, I don't need to test the angles. That's why it's a bit of a shortcut. So if we have 2 triangles and they have 3 pairs of equal sides, they will also have pairs of equal angles. We don't need to test the angles. Similarly, if I have SAS, it means that they have 2 pairs of equal sides and a pair of equal angles. I don't need to test the other pair of sides or the other pairs of angles. Unfortunately, though, the SAS test is a little complicated because it has to be 2 sides and the angle between those 2 sides. Otherwise, you can't use the test, okay? Whereas for AAS, it can be any 2 pairs of angles and any 1 pair of sides. It doesn't matter which ones. So the SAS test can be a little complicated for that. The RHS test means they're both right-angled triangles. You have the hypotenuse and you have another pair of sides. And if that's the case, they will be congruent. I don't need to test the other sides and angles. So to test whether two triangles are congruent, you don't need to test every pair of sides and every pair of angles. You just need three things: combinations of sides and angles. So let's look at some examples of using these tests. Start off with an easy one. So I have two triangles here and they have one pair of equal sides, two pairs of equal sides, and three pairs of equal sides. So they are congruent by the SSS test, three pairs of equal sides. So I don't even need to check the angles in these triangles. I know that corresponding angles will be equal because they're congruent. But the SSS test is enough to show that they are congruent, even though I don't know anything about their angles. So let's look at another example. So let's look at these two triangles here. So they would be congruent because I have one pair of equal sides, two pairs of equal sides, and the angle between. So that's what the SAS test is. It has to be two sides and the angle between. It can't be the angle down here because it's not between the two sides that we have. All right, so I'm going to pause and get rid of these examples, so copy down if you need. So I wanted to show you the difference between the SAS and RHS. So in the top example, we have two pairs of sides. So this time I didn't tell you their side lengths, but I told you they were equal. So we have two pairs of sides, and this right angle is the angle between. So the top is example of SAS, two sides and the angle between. But down here, we still have an angle and two pairs of sides, 1, 2, but it's not two sides and the angle between them. But this one has a right angle, a side, and also the hypotenuse. So this one is the hypotenuse. So this is an example of the RHS test. So you can only use that test in right-angled triangles. So it allows us sort of a way around the SAS test. I've got two sides and not the angle between them. You can only do that in right-angled triangles. All right, let's just look at a couple more quick examples. So these three examples are examples in which there is not enough information to use any of the tests, and therefore we can't conclude that they're congruent. So in the top one, we have two pairs of equal sides and a pair of equal angles, but it's not the angle between the two sides. So we can't use the SAS test. So we don't have enough information to say these two triangles are congruent. We don't have enough information to say that they're not congruent. We can't tell either way. So let's look at this example now. So here I've indicated that we have 1, 2, 3 pairs of equal angles. So if two angles have the same symbol in them, that means that they're the same. That's our way of indicating they're the same. But if you look at our list, there's no AAA test. All of the tests involve information about sides. You need at least one pair of equal sides to prove they're congruent. I don't have any information about the sides here. So I don't know if there are any pairs of equal sides, therefore I can't use any of the tests and I cannot conclude that these two triangles are congruent. So if we go to the third one, this one down here, we don't have enough information. We only have one pair of equal sides. Now it's true that this angle and this angle would be equal because they are vertically opposite. But one pair of equal sides and one pair of equal angles is not enough. You need three things to use the tests. So I don't have enough information to determine whether or not the two triangles are congruent. Note, I would need to be told that this line here and this line here were parallel. That would mean that I have another pair of equal angles. But because I was not told they're parallel, I don't know if the alternate angles are equal. I only have one pair of equal sides and one pair of equal angles, and thus not enough information to conclude that they are congruent. All right, there's one more thing I need to show you how to do, and that is proving that two triangles are congruent. So let's take essentially the last example from the previous slides. Now I'm telling you that there's a pair of parallel lines and I have enough information to show that these two triangles are congruent. But I'm not just going to give you the test that shows it, I'm going to actually prove it. So when you prove it, you're making an argument. You're going through one by one saying why a pair of sides is equal or why a pair of angles is equal or whatever. So how we do that is we list the three things. Remember, each of the tests had three things, combinations of sides and angles. So we list one after the other, 3 lines saying why they're equal, and then we have a concluding statement. So let's start. So firstly, we have a pair of equal sides. So we call that top side AB. That's equal to DE. Now we have to give a reason for that. In this case, it was just given to us. So that's what I write. So now as I said previously, I know that these two angles here are equal. So the angle up here, I call ACB. Remember, it's at vertex C, so C has to be in the middle. So that is equal to angle ECD, which is this angle here. Again, it's at C, so C needs to be in the middle when I name the angle. So the reason that they're equal is they're vertically opposite. So I'm just abbreviating that. So again, I don't quite have enough information yet. I need one more pair of sides or angles. And I know that this angle here and this angle here, they will be equal to each other because I have parallel lines and they are alternate. So I write that as angle ABC equals angle CDE. So I had to call this B in the center because that's where the angle is. This one had to have D in the center because it's where the angle is. And the reason they are alternate angles, they're equal because I have parallel lines. Note, I also, because I had parallel lines, could have chosen this angle and this angle. But I don't need to. Because I've got a side and 2 angles, that's enough information. I don't need to include the green angles as well. So now I write my concluding statement the way I showed you the previous lesson. So therefore, triangles, so I'm going to call the first one whatever I want, ABC, any order's fine, is congruent to. Now, when writing the second triangle, you need to get the vertices in the right order. So see this angle at A is equal to the angle at E, so A corresponds to E, B corresponds to D, and C corresponds to itself. So therefore, triangle ABC is congruent to EDC, and I need to write the test I used, which was AAS. 2 pairs of equal angles and a pair of equal sides. So that's how we prove that 2 triangles are congruent. You need to list why things are equal and then give a concluding statement. All right, sorry for the long video. This has been the luckiest maths teacher in the world. Have a great day.